Welcome to Vijay Chemistry. Okay, we are going to start the lessons F-lock element. It's a very important topic our MSc entrance exam and a CSR and GATE and a PG-TRB and Polytechnic exam. Okay, it's the most important topic. All the entrance exams surely, okay, we accept two questions. Two questions you can expect, okay? Two questions will come. In JAM exam point of view, one question will come. In case of CSR and GATE, two questions. And PG-TRB and Polytechnic, two questions. MSc entrance, two questions. Okay. In the class, what is F-lock element? What is F-lock element? Okay. How to write the electronic configuration, and then which oxidation is more stable, and the color of the complex. Okay. If in case you have F2, F3, F4, what is the color of the F1 element, F2 element, F3 element? That type of concept today we are going to discuss. Okay. First, start the F-lock element. I'm going to give the definition. Please note what is F-lock element. Very important. Please note. Okay. The element. Very important. The element in which last electron enter in n-2, very important, n-2 f orbitals, n-2 f orbitals are called F-lock element, are called F-lock elements. Okay. What is the important key point here? N-2 or n-2 f orbital. Very important. Okay. Which electron is lost? Lost valence electron. Okay. The last electron is entered to the n-1 f orbital are called what? F-lock element. Now see. This is nucleus, right? The shells 1, here 2, here 3, here 4, here 5. For example, okay. This is N. What is N? Last shell, right? This is what? Last shell. This is last shell. This is what? N-1. What is N-1? Penultimate shell. What is N-1? Penultimate shell. Very important. Penultimate shell. What is this? Is N-2. This is N-2. What is N-2? Anti-penultimate shell. Anti-penultimate shell. Now tell me F orbital present which shell? F orbital inner orbital. Okay. Which F orbital belong to in inner n-1, n-2 orbital. Up on the nucleus in between. I mean between what d orbital inner shell. This is very important key points. Okay. Based on this only we're going to discuss what Langonic interaction, right? Understand now. What is the period? What is the group of the F-lock element periodic table? Right, you have to please note. In PT, what is PT periodic table? In periodic table, what is PT periodic table? In periodic table, the lanthanides LN, lanthanides, okay? Actinides AN. My LA na lanthanum is element, okay? LN na lanthanide series, okay? Lanthanum. Period number and group number. The lanthanides period number 6. Actinides is 7. Group on the group. This is very important. Simple question, basic questions. Okay, the group number of lanthanides now 3. Actinides group number 3. Periods number lanthanides on the 6. Okay, actinides on the 7. This is a basic fundamental information about the lanthanides and the actinides. Okay, please a very important key point. Next, general configuration. See, in lanthanum, okay, lanthanides. In lanthanides, which element? Okay, cerium, atomic number 58. Cerium to lutetium, atomic number 71. How many elements are present? Total 14 elements are present. How many elements? Total 14 elements are present. In case of actinides, AN, which element is present? Thorium 90. Thorium to lawrencium. Lawrencium, LR. Atomic 103. How many elements per year? 14 elements present. 14 elements is present. Okay. And today we are going to discuss only one lanthanides. Okay. Lanthanides atomic number. Okay. That's only group. Okay, என்ன group என்ன group third group என்ன period னா sixth period. அது என்ன elements இருக்கு, what is the configuration of that element, அந்த configuration எந்த metal ion most stable. For some case பாத்தீங்கன்னா lanthanides 3+ most stable, 3+ most stable. ஜெனரலா வந்து 3+ most stable. சில ஸ்பீஷிஸ் 2+ most stable, சில 4+ most stable இருக்கு. ஏன் வந்து 2+, 3+, ஏன் 2+, 4+ வந்து ஏன் வேரியேஷன் ஆகுது, I am going to discuss today. Okay, this is very important concept in our entrance exam point of view. Okay, now note what is the general point, please note, general key point, note. Okay, largest period in period table, largest period 6 and 7th, 6 and 7th. How many elements are present? 32 elements are present. 32 elements are present. This is very largest period. Okay, and largest group, which group? Third group. How many elements are present? 32 elements are present. 32. Okay, 32 elements are present. In third group, lanthanides, actinides, yes or no? This consists of what? Lanthanides and actinides. You got the point? Very important. Okay, now what is it? Now going to discuss about what? The lanthanides electronic configuration. Okay, now see, so very important exam point of view. Okay, you need to understand. Please note, put the topic electronic configuration. Now very important. Electronic configuration of lanthanides. Electronic configuration of lanthanides. Okay, very important. Okay, our exam point of view. See, okay, note. Now see, first element cerium, right? Cerium. Second element posodium, Pr. And third element Nd, neodymium. And promethium, samarium, europium, and gallium. Very important, ma. Okay, next terbium and dysprosium, holmium, hirbium, thulium, ytterbium, and lutetium. Okay, now see. Now students, listen. What is general configuration? Please note here. General electronic configuration. General electronic configuration of F-log element. General electronic configuration of F-log elements. General electronic configuration. What is general electronic configuration? N-2 and F1 to 14 and N-1 D0 to 1 and N-S2. Understand? Okay, now N-2 should be 4 or the 4F series. Okay, lanthanides on the 4F, actinides on the 5F. You got the point? If N value 6 are, what is the total value? N-2 4F. 4F. Okay, 1 to 14 and 5D 0 to 1 and 6F. So what? General configuration for what? General configuration for what? 4F element. See, okay, 4F. I mean lanthanides series for a general configuration. Now see, அப்ப இது கண்டிப்பா என்ன இருக்கும்? 4F இருக்கும், 5D இருக்கும், 6S இருக்கும். அதுக்கு அப்புறம் இங்க 4F. Okay, இங்க 5D, இங்க 6S. அதே மாதிரி இந்த இடத்துல இங்க 4F, இங்க 5D, இங்க 6S. அதே மாதிரி இங்க 4F, இங்க 5D, இங்க 6S. அதே மாதிரி இங்க 4F, ஃபுல்லா 5D, 6S. அதே மாதிரி 4F, 5D, 6S. Okay, 4F, 5D and 6X. 4F and 5D and 6X. Okay, orbital. அது இந்த இடத்துல 4F, இங்க 5D, இங்க 6S. அதே மாதிரி இங்க 4F, இங்க 5D, இங்க 6X. Okay, ஃபுல்லா அதே மாதிரி தான். Simple, right? 4F and 5D, இங்க 6X. இங்க 4F, இங்க 5D, இங்க 6S. Okay, very important மா இது. Next அதே மாதிரி 4F, இங்க 5D, இங்க 6S. இங்க 4F, இங்க 5D, 6S. Okay, 4F and 5D and 6S. See, now what is the trick? இதுல பாத்தீங்கன்னா in case of 6S இருக்குல்ல, always put 2 2 2 2 here 2, இங்கேயும் 2 தான், இங்கேயும் 2, இங்கேயும் 2, இங்கேயும் 2 2 2. Simple. Okay, all 6S 2, இங்க 2, இங்க 2. Okay, now இந்த கேஸ்ல இங்க 2 electrons. In case of 5D, very important. first element, 7th element, last element. It means first element, 7th element, last, which is first element, cerium. Which is 7th element, caldonium. What is last element? Lutetium. Okay. For this 3 element only you have to put what? 5D1. Inga 5D1. Okay. Inga 5D1. Inga 5D1. Understand? For all other element, put 0. 0, 0, 0, 0, 0. Okay. 0, 0. Inga 0, 0, 0, 0. We got the point. 0, 0. What is first trick? Put all 6s 2, 2, 2, 2. Second trick on the first element, 7th element, upper 14th element, put 5D1. Matala 0, 0. Now see, in case of neutral state, F2 or F8, which one not possible? F2 and F8 is not possible. Okay. Now I put 1. F2 is not possible. Inga 3. Inga 4. Inga 5. Inga 6. Inga 7. 7th element 7. 7. Very important. Okay. 8 is possible. Inga 9. Inga 10. Inga 11. Inga 12. Inga 13. Inga 14. Is 14 up? 14 or 14. So enough. Okay, this configuration. What is first trick? Very simple trick. For all 6x 2, 2, 2, 2. எதுக்கு மட்டும் 5D1 வரும் பாத்தீங்கன்னா சீரியஸ் first element, 7th element, 14th element. Okay, 5D1. And otherwise neutral configuration பாத்தீங்கன்னா F2 வராது, F8 வராது. Now understand? Okay. Now very important point, please note. Okay, I give you next slide. Please note. The most common, the oxidation state of lanthanide is +3. Which is most common now. The +3 was is a most common, the oxidation of lanthanide. Okay, now +3 possible. See, very important ma. See, there +3 என்ன வரும் பாருங்க. Cerium +3, இங்க lanthanum 3+. Okay, cerium +3 இங்க 2+ அப்ப இங்க 4f1 +3 ல. You got the point? 4f1. இங்க +3 ல இங்க 2, இங்க 1 போய் அப்ப 4f2. You got the point? 4f2. இங்க +3 னா இங்க 2, இங்க 1 போய் 4f3. You got the point? First S move over, right? இல்லையா? 4f +3 னா இங்க 2, இங்க 1 போச்சுனா 4f4. 4f4. அது இங்கே மாதிரி போச்சுனா இங்க 2 போச்சுனா 4f5. 4f5. இங்க 2 போச்சுனா இங்க 4f3 போச்சுனா 4f6. இதுல 4f7. ஓகே, இங்க 4f8. ஏனா இங்க 2, இங்க 1 போச்சுனா ஓகே 4f8. இதுல பாருங்க 2, இங்க 6s2, இங்க ஒரு இடம் 4f what? 4f8. Understand? Okay, inga 4f, sorry, the 4f6. Okay, the 4f6. Wait, 6 or other 4f7. This 4f7. 4f7. Inga 4f9. Inga 4f10. Inga 4f11. Inga 4f12. Inga 4f13. Tappan irukalla, wait panunga. Oh, sorry. Ma, this is 4f8, right? Sorry. This is 4f8, right? Wait. See. This is what? This is 4f8. Now, 2, 1, 8 down. 4f8. This is 4f9. This is 4f10. This is 4f11. This is 4f12. This is 4f13. We are 4f14. Now, understand? Simple, right? Our cerium or cerium 3+ configuration 4f1. In the exam point of view, note paniko cerium, samarium, europium, caldonium, okay, holmium, hirbium, and ytterbium and lutetium. These elements are very, very important our entrance exam point of view. Okay, in the element of magnetic moment kepanga, illa term symbol kepanga, illana or properties kepanga. Purida is general configuration. Okay, now what is the most common oxidation of lanthanide on the +3? But some few elements, the few elements can show +2 as well as +4. It's a possible. Okay, now it's based on, this is based on stable electron. This is based on what? Stable electronic configuration. Based on what? Stable electronic configuration. Very, very, very important point. Now see electronic configuration. Okay, now first example, take okay europium. What is configuration? 4f7, 5d0, 6s2, right? Take europium. Very important ma. Take europium. Very, very important exam point of view. Europium. Okay, what is configuration? 4f7 and 5d0 and 6s2. Now, in case of europium, can show what? Europium 2 plus and europium 3 plus. Europium 2 plus and as well as what? Europium 3 plus. Okay. What is europium 3 plus configuration? In the electron, 4 of 6. 4 of 6. Okay. Europium 2 plus on the 4 of 7. Now, tell me, which is more stable? Half filled, incomplete filled? Always what? Always the half filled what is more stable, right? Which is more stable? The europium, the 2 plus is more stable compared to what? Europium 3 plus. Europium 3 plus the europium 3 plus, very important. Okay, he gain 1 electron, he become what? Europium 2 plus, europium 2 plus. You got the point? What is the reaction? This is a reduction. This is a reduction, right? Gain of electron, reduction. Therefore, europium 3 plus salt, europium, very important, europium, the 3 plus salt is act as what? Act as the good oxidizing agent, good oxidizing agent, very, very, very important in organic chemistry. Okay, europium 3 plus act as what? Powerful oxidizing agent. Because what is the reason? Because europium 3 plus the 4 of 6 configuration and europium 2 plus the 4 of 7, right? It's a more stable. Always what? The unstable form convert to more stable form. It's a universal law, right? Therefore, the europium 3 plus salt always acts as what? The good oxidizing agent. Okay, number 1 point, number 1 example. And second example, see, cerium configuration 4 of 1 and 5D1 and 6s2. Okay. In case of cerium, they show 2 different oxygen. One is 4 of cerium 3 plus. One is cerium 4 plus. What is cerium 3 plus? The 2 1 position 4 of 1, right? 4 of 1. That is cerium 4 plus 4 of 0. Now tell me, which is most of it completely empty, right? It is incomplete. Which is most of always what? Empty most stable, half filled most stable, full filled most stable. Therefore, the cerium 3 plus, okay, is less stable compared to what? Less stable compared to cerium 4 plus. You got the point. Therefore, cerium 3 plus, cerium 3 plus, you convert to what? The cerium 4 plus. Now see, this cerium, right? I go to this slide. Very important. Now, cerium 3 plus configuration is 4 of 1. This convert to what? Cerium 4 plus. Cerium 4 plus plus electron. This is 4 of 0. This is stable form, right? This is stable form. Therefore, when cerium 3 plus undergo oxidation, right? Oxidation reaction. Therefore, the cerium 3 plus salt, cerium, the 3 plus salt is act as the good reducing agent, good reducing agent. Big example, cerium Cl3, right? You see in organic chemistry. Okay, this is what? The good reducing agent in the organic part. Okay, very, very, very important. Second one. Third one, same case, ytterbium. That's also very important. Ytterbium configuration. See, what is ytterbium configuration? Okay, 4 of 14 and 5D0 and 6s2. Understand? Now ytterbium 2 plus and 3 plus. Ytterbium 2 plus and ytterbium 3 plus. Ytterbium 3 plus configuration 2 low position 4 of 13. Right? 4 of 13. Ytterbium 2 plus 4 of 14. Now which is more stable? Always what? Fulfill most stable, right? Ytterbium 2 plus most stable. Therefore what? The ytterbium 3 plus, okay, you gain 1 electron, become what? Ytterbium 2 plus. Which is a reduction, right? It's a reduction. Therefore, ytterbium 3 plus salt is act as what? Act as the good oxidizing agent. Good oxidizing agent. Oxidizing agent. This is what? The very, very important topic is based on what? Electronic configuration. Okay. Please understand. Okay. Most important. Okay. No question. Note paniko. In general, very important. In general, the two elements, the two metal ions, the two element can show abnormal radius, abnormal metallic radius. Which radius? Metallic radius. Which element? Listen, actually, L element 3 plus. L element 3 plus. Now you know A 2 plus A 3 plus A. Is the bigger size? I the positive charge, lower size. Because is the bigger size always A 2 plus bigger size compared to A 3 plus. Up in laminate, which is common oxidant plus 3. Which two element can show plus 2? Europium and ytterbium, right? In case of what? Europium, right? Very important, right? Europium and ytterbium can show what? The abnormal, the metal radius compared to other elements, because these two elements can exist what? The plus 2 state, not plus 3. You got the point. Very, very, very important key points. Okay. This is a previous year, I think CSR question. Okay, CSR question. Okay. What the question now? Which are the following in the pair of two element can show abnormal metal which is answer European metal. Why European metal? In generally all the F flag element can show +3. Only European metal can show +2, right? Compared to 3 plus and 2 plus. So 2 plus bigger size, right? Higher the positive charge, size will be decreases. Okay, this is very important. The problem is based on what? Electronic configuration. Okay. Now I'm going to enter what? Discuss about the colors. Okay. I'm going to discuss color based on electronic configuration. Okay. In the configuration, the color form very important key points our exam point of view. Okay. Now, please note the elements with n number of electrons, n of f electrons, n of f electrons have similar color, have similar color of these with 14 minus n number of f electrons, okay. Now see, I make a box, right? Simple. Okay, we're going to differentiate. Simple. See. Now, very important, ma. See. Okay. Now, here n value. Okay. Here n. Here 14 minus n. Here color. Here color. Now you simply tell, okay, I put F0. What is 14 minus 0? F14. You got the point? Simple, right? Now F1. What is F14 minus 1? F13. You got the point? F2. Therefore what? This is F12. F3. This is F3, no? F11, right? F11. Okay. F4 and F10. F5. Inga F9. Inga F6. Inga F8. Okay. Irikila inga F7. Ingiyum F7. Okay. Just wait, I make box again. Okay, just a minute. Okay. Simple thing, right? We can write simply. Understand? Very simple. Now understand, right? What is the difference? Now, what is statement read against one? What they told? Okay, the Fn and the F14 minus n configuration have the same color. Therefore, F0 and F14 have same color. Which color? Is a colorless. Is a colorless. Very important. More colorless. Very important. Okay, please move. It's a colorless. Okay, it's a colorless. Okay, and F1, F13 colorless. This also colorless. Colorless. Okay, F7 colorless. F7 is colorless. Okay. F2 and F12. This is a pale green. Very important, ma. Pale green color. Very important. F3 F1 rose pink color. This is rose pink color. Exam F4 F10 yellow color. F5 F9 pale yellow color. Pale yellow color. F6 F8 pale pink color. Pale pink color. Motame moone color green, pink, yellow. Okay, va. F0 F14 colorless. F1 F13 colorless. F7 colorless. F2 F12 pale green. F3 F1 pale pink. F4 F10 yellow color. F5 F9 pale yellow. And F6 F8 pale pink color. Okay, this way you have to memorize. Very important. Okay, this is most important exam point of view in our Polytechnic TRB and MSc entrance. Okay, and CSR gate and exam. Okay, it's the most important topic in our entrance exam point of view. Okay, I hope you understand. Okay, how to write the electron configuration. What is general introduction of F-lock elements. Okay, and next today I'm going to discuss the laminar contraction and separation method of f log element. Okay, and thank you so much for watching, and see you next video as soon as possible, and tada, bye bye, and take care.